Find a minimum cost spanning tree on the graph below using Kruskal's algorithm. All right, so Kruskal's algorithm, we go through and we find the cheapest connections we can. For example, this 3, definitely a cheap connection. So let's connect that one up. Okay, what's the next cheapest one? This 12. What's the, oh, the 11. Sorry, the 11 was cheaper. And then the 12. Now, at each time that we add a graph, add an edge, we want to ask ourselves, is this a connected graph? Once it's connected, we stop Kruskal's algorithm because we're trying to find a spanning tree, which is a minimum connected tree. No circuits. Okay, so moving on, what's left is to connect this little piece to this other piece, and the connections possible are a 21, a 32, a 66, a 23, a 24, or a 23. And definitely the cheapest one is this little one right there. And it's also, oh no, it's not the next one on the list. The next one on the list from Kruskal's algorithm would be this 18. But you don't connect a circuit. That's not going to be the minimum. So we'd skip 18, move on to 21, and that would be the final answer. So that shape, whether you recreate it or just highlight it in some way, in this case we want to find the minimum cost spanning tree, so we want to show the tree. This is probably the safest thing to do, is to recreate it. If you wanted to find the actual weight of the minimum, 12 plus 21 plus 11 plus 3, and you would get 47. So Kruskal's algorithm is not difficult. You add edges that are the cheapest, not making a circuit ever, until you have a connected graph, and then you're done. So go ahead and pause the video as you work on these questions on the right. All right, so the top one, you should end up with, let me create, the picture. This shape. That's the cheapest connections. And it is the first time it's a connected graph, and the weight of 88. The bottom one, your picture should be like this. And the weight, the cost of that minimum cost spanning tree is 56. All right, I hope this helps.